Welcome back. I am Okpe, my name. So today we'll be dealing with ICT, and under ICT we'll talk about logic circuit. Under this logic circuit, we'll talk about the definition, the types, and their symbols. So first of all, what is logic gate? Logic gates are electric circuits that manipulate voltage. The types of logic gates. Number one, we have the basic gate, we have the universal gate, we have the special gate. Under this basic gate, we have AND gate, OR gate, and NOT gate. Universal gate, we have the AND, we have the NOR gate. The special gate, we have the XOR gate, we have the XNOR gate. So let's discuss. First of all, we'll deal with basic gate, which I've written here on the board. Number one is AND gate. This is a symbol for AND gate. In AND gate, we have two inputs. These are inputs, two inputs, and one output. So this is the symbol for the AND gate, and this is a truth table. So now we move to the truth table of the AND gate. This is a diagram, or this is a table for the truth table. The truth table is written as the input and the output. Since I said we have two inputs here, this A and B, and our output is 1. This is y is equals to A and B. The reason why we have dot here is because in AND gate, its operational is represented by what? Multiplication. So this is a truth table. We have 0, 0, 0, 1, 1, 0, and 1, 1. So the output is going to be multiplication sign. This dot means multiplication sign. So 0 times 0 is what? 0. 0 times 1 is 0. 1 times 0 is what? Is 0. 1 times 1 is what? Is 1. So that is, these are just some of the things you need when you are doing your AND gate. AND gate, it has two inputs or more inputs and only one what? Only one output. It represents multiplication operation. So that is for the AND gate. So the second one under this basic gate, we'll talk about OR gate. OR gate symbol, it is drawn like this. Mind you, it is drawn like this one. It represents what? Additional operation in AND. In OR, sorry. While in AND, it represents what? Multiplication signs. So this is a truth table for your OR gate. This, sorry, I made a mistake here. So this is still the same thing with this number. This number, the input is constant, it doesn't change. Same thing with this one also, it doesn't change. So the only thing that changes here is the output. Here. The output here and here, it is different because of what we are doing with multiplication sign here, and we are doing with what additional sign here. So now the output for the OR gate is going to be 0 plus 0 is what? 0. 0 plus 1 is 1. 1 plus 0 is what? Is 1. 1 plus 1 is what? Is 1. Because in computer studies, we deal with what? Zeros and 1, binary. So under this, that is, it has 2 or more inputs and only one output. 2 or more inputs. 2 or more inputs and only one output. It represents additional operation. We are using additional operation to get the what? To get your output. And what if one of the input is high? If one of your input in your truth table is what? Is high. That means automatically your output here, it is high. So next, now we move to the last part of the basic gate, which is the NOT gate. Another name for NOT gate is what? Inverter. In case if you are solving any question, they ask you to draw the symbol for inverter, they are simply asking you to do what? To draw the symbol for a NOT gate. So this is the symbol for the NOT gate. This is the symbol and this is the truth table. So in NOT gate, it only have what? Only have one input. So the NOT gate is different from the OR gate and the AND gate that we have talked about before. So and only have one output. So this is the table for the truth table. So the A and the A bar, 0 and 1, 1 and 0. If this one is 0, if this one is 1 rather, this is automatically 0. And if this is 0, this is automatically your 1, A bar. That's the complement of the what? Of your input, A. So now we move to the second part, which is what? Universal gate. So now the universal gate, I said we have the AND gate. So this is symbol in AND gate. From the name itself, you can see is combination between two gates, which is what? NOT and the AND. This is the symbol for the AND, and this is the symbol for the NOT gate. So in AND gate, it has what? Two inputs and one what? And one output. So since I said it's a combination of NOT and, this is the first diagram and this is another diagram. That's in the case whereby you have to draw it. So yeah, you can draw either this one or this diagram. Is okay. And this is the truth table for the AND gate. The truth table is the input and the AND. Which the input is what? Is the AB. This is your AB and this is your AB. And this is the AND. You know, as in the previous lecture, we have solved this AND. So whatever you get there, you input it here. That's your AND. Now we are trying to look for what the AND gate, which I said is a combination of the NOT and the AND. So this is A dot B, that's A multiplied by B bar. So A multiplied by B bar is the what? Is the complement of this A times B. So any answer you get here, you are going to change it. That's the inverse of A dot B bar. So this A, 0 times 0 is what? 0. 0 times 1 is what? 0. 1 times 0 is what? 0. 1 times 1 is what? 1. So these are A dot B multiplication sign. We change it as the inverse is going to be the 1, 0 change to 1, 0 change to 1, 0 change to 1, and 1 change to what? 0. The next one is the NOT gate. NOT gate. Like I said when we were discussing this NAND gate, I said it's the combination of what? NOT and the AND. So same thing to this NOT gate. It's a combination of the what? Of your OR gate and your what? And your NOT gate. So this is the diagram. So it is either you draw it this way or this way. It's still the same thing. So now we move to the what? To the truth table. So in the truth table we have two inputs, A and B, A plus B, Y is equals to A plus B bar. So A is 0. This is your first input. 0, 0. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. The reason why we are having 1 here is because in computer studies we don't deal with any number apart from zeros and 1. So this is going to be, the answer for this is going to be the inverse of A plus B. So we have a 0 here, so this one is going to automatically change to what? To 1. This one is 1, 0, 1, 0, 1, and 1. So now we move to the last part under the types of logic gate, which is the special gate. The first one here is the XOR gate. It can be written XOR gate or XOR gate. Either of the two, it is correct. So, and these are the short notes you need to understand your truth table. So which I said, if any one of the input is low, if any one of your input in your truth table is low, then the output must be what? Must be high. And this is the symbol for your what? For your XOR gate. This is it. Y is equals to A modulus B. Then your truth table, the input and the output. Your A, B is equals to, then Y is equals to A modulus B. Your normal diagram, that's a normal number. That's 0, 0, 0, 1, 1, 0, 1, 1. If you observe this number on the AND gate, you'll see it is the same thing. It doesn't change. It is constant. So, like I said earlier, I said you need this to understand your truth table. So now, from what I said now, if any one of your input is low, any one of our truth table here, if any one is low, not the two, only one. So that means what? Our output here is low. So like here now, we have, sorry, if any one of the input is low, then the output is high. Where we have 0 is low, automatically our output is what? Is high. Here our input is what? Is low, here it is high. These two, they are high. So this is 0. And these two, they are low, automatically this is 0. Now, we move to the last part of the special gate, which is XNOR gate. XNOR gate. XNOR gate. So it has 2 or more inputs and what? Only one output. So the output is the complement of your what? Of your XOR gate. XOR gate from that previous diagram that we did. XOR gate. So this is diagram for your what? For your XNOR gate. This is the symbol for the XOR, if you can remember. Why this symbol for the NOT gate, if you can remember from our previous classes. So why? Is that you draw this or you draw this diagram. Both are correct. Because what is the combination between NOT and the XOR. So this is a truth table for your what? For your XNOR gate. Input and output. The input, I said we have two inputs, this A and B. These are constant. It doesn't change. If you observe 0, 0, 0, 1, 1, 0, 1, 1. It's constant. And this is A modulus B. I said it is the output of the complement of XOR. What we got from our XOR. This is a symbol for what? XOR, A modulus B. So you bring it back to this side because it's what is the combination between the XOR and the NOT. So A modulus B, bring the number to this side, while A modulus B bar is going to be what? It's going to be a complement of the XOR. So that's how we got 1, 0, 0, and 1. Hope you understand. So now we move to the uses of logic gate. It is used in traffic light control, and number 2, it is used in ALU, arithmetic logic unit.
Yeah.
Now we'll solve some examples under what? Under the logic circuit. So our first example now, this is an objective question in WAEC. So we asked to what? To identify this figure 1. This is what? In figure 1. Figure 1 represents A, an AND gate, B, OR gate, C, NOT gate, D, NAND gate. Can you solve it? Figure 1 represents A, AND gate, B, OR gate, C, NOT gate, D, NAND gate. If you can remember when we are solving all those type of gates, I drew something like this, which simply means the answer for this diagram or for this question is what? Is OR gate. So the question number 2 now says that in this figure 1, X and Y, X, Y, and Z representatively represent what? This is your X, this is your Y, and this is your Z. What does it represent? Is it A, input, output, and input? Does it mean this one is input, and sorry, does it mean this one is input, this one is output, and this one is input? Does it mean B means output, and this one is input? C, output, input, and output. D, input, output. If you can remember when we were talking about the OR gate, I said it has two inputs and only one output. So the answer is what? It is D. Input, and output. Now we move to the last example, which is what? One says that given that X equals to 1, 1, 0, 1, 1, 0, 1, 1, and Y is equals to 1, 1, 1, 0, 1, 1, 0, 1. A. Construct the truth table for X dot Y. What does this sign represent? That's multiplication sign. Is equals to Z. B. Draw the logic gate of X dot Y is equals to Z. C. State the value of what? Of Z. So let's solve. The question says that given that X is equals to 1, 1, 0, 1, 1, 0, 1, 1, and Y is equals to 1, 1, 1, 0, 1, 1, 0, 1. So you have to do what? Construct a truth table for this value. So it's going to be X so which simply means X and Y are what? They are your inputs in this diagram, this logic gate. So X is what? 1, 1, 0, 1, 1, 0, 1, 1. Your Y is what? 1, 1, 1, 0, 1, 1, 0, 1. So you just did what? We just constructed what? The truth table for what? X dot Y. X dot Y is equals to Z. So now, what's going to be our answer for the Z? Can you remember this sign? This is multiplication. This is multiplication sign. So 1 times 1 is what? 1. 1 times 1 is what? 1. 0 times 1 is what? 0. 1 times 0 is what? 0. 1 times 1 is what? 1. 0 times 1 is what? 1. 0, sorry. 1 times 0 is what? 0. And 1 times 1 is what? Is 1. So this is the output of your what? Of your x and y. So the second question now says that draw the logic gate of what? Of x dot y. The logic gate, since we said this dot means multiplication, so that means we are drawing the logic gate of what? Of AND gate. So answer to question number B is going to be AND gate. AND gate. X, Y, Z. 2 inputs and 1 output. So question number 3 now says that state the value of Z. C. State the value. You have solved the answer already. So just write it. 1 1 0 0 1 0 0 1. So this is the value for what? For Z. I hope you understand. Thank you.